So I've been making some cool stuff since the last time. I designed a smart bone, a linkage between joints. My printer once again had some trouble. I started putting together the systems for visual monitoring of the robot. We're practicing. Oh no! Better reset. I'm Josh Whitman, CEO of Whitman Technological. As I developed the software, it became clear that the robot needs a lot more sensors than it currently has. Nephele 2.0 has the accelerometer and gyroscope, as well as hip angle sensors. Nephele 2.1 will have smart bones for the hips, as well as above and below the knee, in addition to having angle sensors for the wheels, the knees, and the hips. Once it occurred to me that I didn't have enough sensor data for the next stage in the robot's software development, I started thinking about how to add more sensors to it that could give me the information I needed. Eventually, I settled on strain gauges. Now, these things are exactly what's present inside like a bathroom scale. They're made out of a copper alloy called Constantin, and that changes voltage very reliably when it's under load. I did some quick calculations on how much deformation my little strain gauges I ordered could withstand before they failed, and then how much force it would take to flex a certain size of ABS plastic. So I hopped into FreeCAD and I designed this linkage with this little bridge component. And then I sent it off to my printer. I did the two core pieces in ABS and then the longer linkages in PLA. But for some reason my printer stopped printing PLA. So we had to figure out what was wrong there. It turns out the fan, the little cooling fan that goes on the heatsink, 6 years of running without stopping was as much as it could handle. So I bought a new fan, I swapped in the new fan, I mounted it a little bit more centrally on the new heatsink. Ooh, that's got a good breeze to it. And that keeps the heatsink nice and cool. Now the PLA goes all the way through the tube before it gets to the hot end and starts melting, so it no longer jams up. Everything's back in action. I used some Gorilla Glue to attach the strain gauges onto the bridges, and then I tried to solder wires directly to the strain gauges and discovered that the force from the wires was going to break the strain gauges. I had to scrape one of the gauges off and glue a new one on because I broke it. So I needed something more stable to attach the strain gauges to. So I quickly designed a very simple, it's basically just wires, little pieces sticking off the ends of the triangle pointed at the sets of strain gauges that I would need to wire to, and then a central set of wires that comes off. I fired up my router and generated the circuit board. It's a piece of cake these days, which is awesome. After the board tested out to be continuous where it should be and not where it shouldn't, I glued it inside the smartphone, and then I attached wires from the strain gauges to my little circuit board. This was a very delicate and tedious process, but ultimately not impossible. And ultimately glued all the pieces of the linkage together to make one completed smartphone. See, I'm doing this so wrong now. But like this is already ruined, so it doesn't glue, that's fine. We'll just do something else. I stuck three 24-bit analog to digital converters onto a breadboard and fed the voltage signal from the pairs of strain gauges into these converters. After writing a little bit of code in Arduino, I was ready to start reading the sensor data off of the smartphone for the first time. We can see that the sensor data is going up and down just like we hoped it would for a single strain gauge. So now it's time to write up the code for all three of the strain gauges together. You can see all three strain gauges working 120 degrees out of phase of each other, just like we'd expect them to. So I need all this extra sensor data because the way I think the software architecture is going to work out is that I'm going to have three kind of separate entities within the system that have different responsibilities. The first system is going to take the sensor data from the robot, the accelerometers, the torque and force, the joint angles, and it's going to determine the robot's posture. The second stage is going to compare the current posture with a target posture and produce a array of parameters that will apply on the third stage. The third stage is the node array that I showed in the previous video, where there's a whole bunch of parameterized functions that take the sensor data and convert it into motor control data. In order to make these generative, there has to be a way to train them, a way to indicate that you are successful or not successful at accomplishing the desired task. So splitting it up into three separate chunks makes that much more manageable. The basement's a little messy, so I picked up all the wood and random stuff and some garbage that was there. Cleared out a nice area for this training environment for the robot, where it'll kind of be protected from wandering off and like starting fires or breaking things. I got to break out my new saw for the first time and cut some 2x4s down. I had just enough 2x4s on hand to make a really crappy frame system. I had 2 sheets of drywall on hand also. Oh my god, I don't know. Good thing I did all 6 of these before I realized that that was just completely useless. Oh, no, I only did 5. Like a genius. Why is this so warped? Ugh. Perfect. Everything's fine. Nothing is broke. Uh-oh. Hammer and nails, you're embarrassing me in front of my friends. God, why was this so much harder the second time? Alright, little spider, you got a student.
Why does that look so bad?
And that squares off a little section of the basement as a nice little training environment for the robot.
Oh, no! No, 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 no. Oh, God, this works. Oh my God, that was close.
I have two cameras that sit on either corner of the entrance to this area and will watch the robot as it moves around. And hopefully I'll be able to collect enough information to successfully train a position detection algorithm, and that'll be fun. I added the ability to collect a camera feed onto the software that I've been building for the robot. And from this camera feed, I can extract the raw bitmap data for the individual frames, and I can do this for multiple cameras and synchronize the frame captures. I played around for a bit with different ways of manipulating the pixel data to just play with, like, if I oversaturate, if I look for boundaries and random stuff like that. Had a bunch of different kind of versions of the image that I could generate, just so that I knew that I was manipulating the actual bits of the image correctly. I'm not doing really any processing on it at this point, but I am directly manipulating the raw arrays of pixel data, which is good. That should be fairly high performance, and it will transition well into a real-time machine learning object detection kind of setup. If you have any tips for creating or working with surface mount device based circuit boards, leave them in the comments for me. I've never done it before. I'm going to be trying it in the next month or so. So any advice you can give me would be really appreciated if that's something you have experience with. Thanks for watching. I'm Josh Whitman with Whitman Technological. I love science, and I hope you do too.